Hi everyone, and welcome to my video about naming organic molecules. This is designed for students just starting out. So NCEA Level 2 Chemistry is what it is aimed at. And at this level, there's only a small number of functional groups that we study. So that makes the various different names a bit more straightforward than they could be. I like to think of the naming system as being made up of 4 parts: prefixes, roots, saturation, and suffix. And underneath each one of those headings, I've written down what they refer to in terms of the structure. I've also got some flashcards of what the different functional groups are, and I've lined them up with the relevant section of the name. There's no functional groups lined up for the roots section, because that is simply telling us how many carbons there are in the longest chain of the molecule, and we use these words to show that. So let's get an example for this, such as this. It is an alkane, it's got single bonds, it can be twisted in many different perspectives, so I could draw it on the page more or less any way I really wanted to. For clarity, it would be drawn in a straight line because it's just much more straightforward to see what's going on. Okay, when it's drawn on a page also, all the hydrogens that are branching off the carbons with bonds, it's quite tedious to draw all that, so what's commonly done is that the hydrogens are squashed in as part of the main chain. They're not actually part of the chain, they are still branching out, but it's just a much easier way of drawing it, so it would be drawn on paper, something like that. The first carbon's got 3 hydrogens attached, so that's why it says CH3, next one's got 2, and so on and so on. So going through piece by piece. In terms of prefixes, this molecule does not have any amines or halogens, and there are no carbon chains branching out, so it won't have any prefixes. It will have a root of the name that needs to include a chain of 6 carbons. 6 is hex. The next thing I look for is the bonding between those carbons. Are there double or triple bonds? Because there isn't, the default saturation is ane. And then at the very end, is there an alcohol or a carboxylic acid group? If there isn't, an E is put on the name, essentially just to round it off and make it easy to say, I guess. We've got hexane is what our structure is there. Straight chain alkanes are very easy to name, simply because there isn't really much to them. Let's stick a branch in there now. I've got 3 carbons in a row and there's 1 branching off the middle. In terms of how I draw it, really, it doesn't really matter which way around I draw this, in terms of does a branch go up, does a branch go down, it's irrelevant. When I draw it, I'm going to squash all those hydrogens in and make it a condensed formula, because drawing all these sticks just becomes really tedious. So this is the structure we're dealing with. I can see in this that off the main chain there is a piece branching off. It's 1 carbon big. It's a carbon side chain. The carbon side chains are named using the same system as the root of the name. IL is written on the end of them just to signify that we're dealing with the carbon side chain itself. Okay. The main chain is going to encompass all of these. There's 3 in a row, so we'd write them prop. The next section is the saturation. No double or triple bonds. The ending is an. No acid, carboxylic acids or alcohols, so the final ending is E. We'll come back a bit more about this in a second. But if I have something located on my main chain, it needs to essentially be given a street address, I guess, in terms of telling you where it lives. Okay, so I could either call this number 1, this 2, or this 3, or this one number 1, this one number 2, this one number 3. Ultimately, either way around I write those numbers, I'm going to find that at number 2 there is a methyl side chain, and it is attached to propane, so I'm going to call that 2-methylpropane. We might come back to this a little bit because this 2 is essentially an optional number because the side chain couldn't be anywhere else in this molecule, but there's no harm in having it there. We're just going to leave it there and move on to another example. Now we have 4 in a row. There's actually a double bond inside that right there. So on paper, we're going to draw something like that. The double bond is of course between these 2 carbons. These hydrogens are actually all branching out. This is just a way of writing it that's easy to do, particularly on a computer. One piece at a time. There's no prefixes, no side chains, halogens or amines. If the longest chain is bute, the fact that it has a double bond inside it, that's going to cause the saturation to become ene. And in terms of the vinyl suffix, there's no alcohol or carboxylic acid, so the ending is going to be capped off with an E on it. So, put together, we have bute. There's a gap between those because, just like with the methyl group from the earlier example, we need to show exactly where the double bond is living along this chain of carbons. Whenever I do this, there's absolutely no reason why you would number in the same direction you read a piece of paper, because this molecule could have been drawn around that way, or it could have been drawn around that way. So the numbering will not always go from left to right, 1, 2, 3, 4. It could possibly go the other way. So I guess the question is, well, which way do we go with? We go with this whichever direction gives the lowest possible number to our functional group. If I choose a first set, the double bond starts at number 1 and it goes to number 2. If I go the other way, it starts at number 3 and it joins up with number 4. So obviously, these numbers are not going to be the ones we use. We can use a second set, and we're going to say that this is bute 1-ene, because 4 in a row, double bond starting on the first carbon in from the end. Now let's put in a few more functional groups and see how much it changes things. I now see that I have an O to an H. That is going to be an alcohol functional group. It is going to be a suffix. I see a green atom signifying chlorine. That's a halogen, and it's going to be a prefix. And obviously there's going to be a root of the name of bute and a saturation just because it's all single bonds. When I draw it on paper, I could draw it that way, or really however I like. I've gone this way around, so the chlorine's on the left and the OH is on the right. And I have to build the name. The chlorine is a prefix and it's chloro. If it was bromine, it would be bromo. Iodine would be iodo, and so on and so on. And alcohol, OH, is a suffix of ol. And the main carbon chain is a total of 4 in a row, bute, single bonds all the way through, and it's going to be the end. I'm not going to put an E on the end of there because the ol is a suffix. It's going to become the end of the name. So one piece at a time, all in one string, chloro, butane, ol. There's a gap in there because the alcohol could occupy any one of the 4 positions in this molecule, and I need the name to represent precisely where it is. So I essentially give the street addresses. But the question is, do I go with numbering left to right or right to left? This is where numbering priority comes in. It's written along the top here. There's an arrow pointing that way. What it signifies is when we have a chain of a carbon chain, whichever direction we number it must give the lowest possible number to whichever functional group appears last in the name. That means if you have an alcohol, the carbon it's on must have the lowest number you can possibly give it. If there's also an alkene inside there, because the alcohol is near the end of the name, it will take priority. So these ones are most important for the lowest numbers, followed by the bonds, and then it jumps all the way across to the prefixes. So in this case, the alcohol is more important for numbering than the chlorine because it appears at the end of the name and this one appears at the front. Which means, using the bottom system of left to right, the alcohol is at number 3. I can do much better by making it number 2, which means I actually number that direction. The alcohol is at number 2, the chlorine's at number 3, and that would be the name for that molecule. Possibly just one more to finish us off. This will do us. Just what I'm looking at is I can see a C double bond O and then an OH. That's going to be a carboxylic acid, and then I've got an NH2 on the side. That's a amine functional group. So I'm going to include both of those 2 parts in the name. In terms of writing it out, we'll just go like that. 4 carbons in a row, there's an NH2 at one end and there's a COOH at the other end. Naming one piece at a time. Presence of this is going to be a prefix of amino. I've got 4 carbons in a row. That is going to be bute. Also, along that carbon chain, no double bonds between them, or triple bonds, so it's an. There is a double bond over here going to an oxygen, but because it's not part of this chain, that is not what the saturation shows. And the final piece is this bit here. That's a carboxylic acid. Oic acid is a suffix that represents that. A common mistake for students is to not include this carbon as part of the main carbon chain because it's being counted in here. It is still 4 carbons in a row though, so you've got to leave it in. It's butane as opposed to propane in this case. And so the final step is putting the numbers in. Only carbon atoms get numbers, so there's no number that's assigned to the N. And the carbons could be called 1, 2, 3, and 4, or 1, 2, 3, and 4. Thinking about numbering priority, the things at the end of the name have got more priority than anything else that comes along in terms of the lowest number. So this is what we need to give the lowest number to because it appears later in the name as a suffix than it does in this, which is a prefix. So giving it number 4 doesn't make a lot of sense when we can give it number 1. So we're going to go with the top sequence. I'm actually numbering right to left, but that's okay because I have to use a numbering priority system. I don't always number the same direction that we would read a page. So that means I have got, if it was all to be assembled, at number 4 there is an amine. So at 4 amino, there's 4 carbons in a row, all single bonds between them, and I have got an oic acid. I'm going to leave a gap for a number of that, but we're going to close that gap very shortly because of this. This is what a carboxylic acid essentially is. Double bond to an oxygen, another bond to an O, then to an H. Because a carbon can only have 4 bonds, there's only one more bond available for it to join on to a carbon chain. That means we can't have this and have more than one carbon bonded directly to it. There's no bonds available. So it has to end up being the last thing on a chain. So it's always at the end of a chain. And because it has numbering priority, it's actually always number 1. So what we'd actually do is we wouldn't put a number inside there because there's no need to say it's butane 1 oic acid when that can't be anywhere else. So 4-aminobutanoic acid is what we have. Numbers are not required if there's only one possible place for that thing to be found. That's true for all carboxylic acids, so a number won't ever appear there. Just as an aside, I did mention we'd come back to this number here. This number here is actually also essentially optional. It's redundant because if you have 3 carbons in a row and you have a side chain, you can't put this side chain on here or on there because then you just get 4 in a row or 4 in a row. So for some cases with side chains, there's no reason to have a number because it has to be somewhere in the middle of the chain. In this case, there's only one middle, so it's always going to be located in the middle atom. We could write methyl propane and still be equally correct. It does take a lot to get used to at first, but it's quite systematic. One of the key things is that if you can't recognize your functional groups, then you'll never be able to make sense of a name. So it's very important to learn these things, have them as flashcards with the functional group and the naming component, something like that. And then it's just a case of following the system, and you'll always get the right answer. There is more to this than what we do in level 2 chemistry. All the suffixes can actually have a form, which is going to be a prefix, and that's sometimes necessary. It's not for this level, so we can just keep it simple and go with that. Thanks for listening.